Let's talk about Java primitive data types. There are several primitive data types in Java, and they are mostly used for saving numbers in memory. In this video, I'll show you how to use them in your programs. Java language has 4 primitive data types for integer numbers. Let's start with the smallest type, byte. The byte data type is an 8-bit signed integer. It has a minimum value of -128 and a maximum value of 127. The byte data type can be useful for saving memory in large arrays. Let's create a variable of byte type and put something there. For example, 34. And then let's print this value to the console. And run the program. So it works. Then try to put something negative there. And you can see that it might hold negative values. Okay, what if we want to know the biggest and the smallest value this type byte can contain? Can we know that? Of course we can. Let's use byte class for this purpose. And let's find out. Maximum value of byte data type. And byte class, and we have this value here. And the same action for minimum data type, for minimum value. And let it be something like here, byte data type. Let's run this program. And here we can see the maximum value of byte data type and the minimum value of byte data type. Okay. Let's look at the next data type. This is short data type. Short data type can contain much bigger numbers and much lesser numbers than byte. It will be sh. And let's change it to something else. Sh and short. We also can easily get the answer about maximum value and minimum value for this type, short. We can use class short for this purpose. Let's run the program. And this is it. The biggest number of short data type and the smallest number. Next type is int. This is the most common type which can hold integers. And int means integer. Let it be I variable. It can be very big integer number or very small. And let's find out the range of values of int type. So we can have integer type for this purpose. And let's run our program once again. So for int data type we can use much bigger numbers or much smaller. And finally we can use the biggest primitive data type for integers, and its name is long. So we can use long keyword here and let it be L variable, some different number. And let's add long here, long, and long class. let's find out information about long data type. And as you can see, this is 64-bit integer, so you can hold very, very big numbers there. And let's fix these variables, I and L. But what if we hold floating point numbers in our int data type? How can it be? Let's try. For example, I want to assign 1.3 to my I variable. Can I do that? As you can see, we just can't. We cannot assign floating point numbers to our integer types. Byte, short, int, and long can be used only for integer numbers. And for floating point numbers, we have different types. For example, float. This is proper type here. We can use it for such numbers, for example. As you can see, the compiler doesn't want to allow this line also. It's because this particular number has type double. Because in Java we have one more floating point type double. And this number, by default, is the value of double data type. Let's look at this code. If we try to assign this particular value to double variable, it will work. But what is the difference between these two types? Float type can hold 32-bit floating point numbers, and double means double precision. This is single precision number, and this is double precision number. And double type has 34 bits per one value. And when you write something like this, by default this value has double data type. And float data type might be used for saving memory, because 4 bytes is much less than 8 bytes in memory. And if we have large arrays of double values, we can easily save the memory by turning double to float in big arrays, if we can, if it's possible, of course. So, for this assignment, we need to add this F letter at the end of the value, and it will mean that this is 2.34 is float value, and it can be easily assigned to float variable. Okay, let's print these values to the console. And this variable, and let's print this one, double data type, and this variable. Let's print. And as you can see, we can hold floating point numbers in both types. Okay, but what about minimum and maximum values for each type? Let's find out. And we need to use float class here and here. And for this type, we can also use double class. And double here. So let's run our program. And here you might see that in double type you might hold much bigger numbers, and it will have double precision. That's why sometimes it is much better to use double type instead of float, but of course it will cost you much more memory. The next primitive data type is char. It can hold single Unicode character. And we might use this something like this. And let's print this character to the console. Let's run the program. And you might see this character here. Pay attention that you should use single quotes here. Because if you use double quotes, it will mean string, not a char. And also, you can assign a code of char there, not only char. For example, it might be something like this, 65, and let's use ch2. And you might see lower a because we assigned it here, and here we can see capital A because the code of capital A is 65. And we might change the code. 97 is small a. And last primitive data type is Boolean. Boolean variable can hold only two values, true and it might be false. This type is very special. Usually it's used in conditional operators, such if operator. And let's print these values to the console. Boolean and let's run the program. And you might see that the values are true or false.